Today we're going to be continuing on working with radicals, but we are going to start with multiplying them. And there are going to be 3 steps when you are multiplying radicals. So step 1, we're going to multiply our coefficients. Coefficients are the numbers in front of the radical. Second, we are going to multiply the radicands using the product rule. And radicand is what's inside the radical, so we have A is our radicand in our first one, and B is our radicand in our second one. So this would become square root of A times B. And then step 3, we need to simplify the resulting radical if we are able to. So whatever is your new value inside your radical, we need to simplify that and pull whatever we are able to out of our radical. So we're going to look at some examples. For number 1, we're going to find each product and write our answer in simplest radical form. So step 1, I'm going to multiply my coefficients. So I have radical 8 times negative 3 times radical 2. So in this first one, radical 8, my coefficient is just 1 because there's nothing there. My second one, it's going to be negative 3, and we need to keep that negative sign with it. So negative 3 times 1. Just going to leave me with still negative 3. Step 2, we're going to multiply the radicands. So what's inside the radical? So I'm going to take and write a radical, and I'm going to do 8 times 2. So then I'm going to have negative 3. Radical 2 times 8 gives me 16. And while you're doing this, make sure you have that cheat sheet of your perfect squares out, because I see right here that 16 is a perfect square. So for step 3, we're simplifying the resulting radical. We can take and do the square root of 16, which gives me 4. So this becomes negative 3 times 4, and negative 3 times 4 gives me negative 12 as my resulting answer. So this one is going to equal negative 12. For number 2, I have radical 3 times negative radical 2. So looking at my radical 3, my coefficient out of front is, again, 1 because there's nothing there. And then on the second one, I have negative radical 2. So that negative is telling me that there's a negative 1 out in front. So I have 1 times negative 1. It's going to leave me with negative 1. And then I am multiplying my radicand, so I have 3 and 2. So then when I do this out, I'm going to be left with negative. Don't have to write the 1. Just negative radical 2 times 3 gives me 6. So I have negative radical 6, and I cannot simplify radical 6 at all. So this is going to be my final answer. I'm going to go ahead and skip to numbers 9 and 10 to show you guys a little bit more complex of problems. And just a little friendly reminder here on the left, make sure you watch out for order of operation. So what number 9 is 10 radical 2 times 3 radical 10 minus 6 radical 5. So we have 2 operations in here we need to complete. We have multiplication and subtraction. So we want to start with PEMDAS, so multiplication is going to come before subtraction. So we want to multiply this here first. So when we're multiplying, we're going to multiply the coefficients. So we have 3 times 10, that's going to give me 30. And then inside my radical, I am doing 2 times 10, or 20. And then I have minus 6 radical 5. Okay. Now I need to go ahead and subtract, but I cannot subtract these two because they do not have common radicands. So I am going to simplify 30 radical 2 so that I can see if I can subtract 6 radical 5 from it. So I know that factors of 20 are going to be 4 and 5, and 4 is a perfect square, so I'm going to have 30 radical 4 radical 5 minus 6 radical 5. Then I can take this 4 and pull it outside the radical because the square root of 4 is 2. And then I'll do 2 times 30, which leaves me with 60 radical 5 minus 6 radical 5. Now that I have a common radicand, I can go ahead and subtract these two. So I'm going to subtract my coefficients, so 60 minus 6, and my radicand is going to stay the same. So 60 minus 6 is going to give me 54, and I still have radical 5. So 54 radical 5 will be my final answer. Number 10 is going to be a little bit trickier. We've got some exponents mixed in there, and we have two operations. So we have addition and multiplication. So I have 7x cubed times radical 6 plus radical 12x squared times 2x to the, radical 2x to the fourth, So, order of operations, we need to do our multiplication first. So the 7x cubed radical 6 is going to stay just as it is. And then I'm going to have plus. And so first things first, we're multiplying our coefficients. In this case, they're both 1, so I don't need to write that. Then we're going to multiply what is inside the radical. So first, starting with 2 and 12. 2 times 12 gives me 24. Then I'm going to use my product rule. So I have x squared times x to the 4th. So when I'm multiplying, I'm going to keep my base, which is x, add my exponents. 4 plus 2 is 6. So I now have inside this radical 24x to the 6th. I need to then go ahead and simplify this because in order to add these, I need both of them to have a common radicand. So I have 7x cubed, radical 6 still, plus 24. I know I can multiply 4 and 6. So 4 is a perfect square, so I'm going to pull that outside the radical as root of 4 square root of 6. And then I have x to the 6. And 6, we learned if that is a multiple of 2, we can go ahead and take that and remove it from the radical. So I'm going to put that over here. And we can do 6 divided by 2. So rewriting this so it's a little bit cleaner, I have 7x cubed square root of 6 plus. I can do square root of 4, so I'm going to also remove that from the radical. We know that is 2. So I have 2x to the 6 divided by 2 gives me 3 square root of 6. Now that I have a common radicand, I'm going to go ahead and add my coefficients. So I have 7x cubed and 2x cubed. So I'm not going to do anything with that x cubed when we're adding common or like terms. X cubed stays the same. We add 2 and 7. So I'm going to have 9x cubed now. And then square root of 6. So my final answer for this problem is 9x cubed radical 6. Moving on to the second page, there are going to be times where you need to use the distributive property when we're multiplying radicals. So in this example 1, we have radical 6 times in parentheses 3 plus radical 8. So we need to take this radical 6 that's outside the parentheses and we're going to distribute it to both terms inside the parentheses. So we're going to do radical 6 times 3 first, which it's just going to leave me with 3 radical 6. And then I need to add that to radical 6 times radical 8. So no coefficients there, so we're just going to take and multiply what is inside the radical. So 6 times 8. So I'm going to have radical 48. Now I can't add these because I need to go ahead and simplify radical 48 first and see if they have a common radicand. So 3 radical 6 is going to stay the same. For radical 48, I know that you can multiply 3 times 16, 16 being my perfect square. So this is going to be plus radical 16, radical 3. So next step, when I simplify this, the only thing I can simplify is going to be that radical 16, pull it out of the radical. So we're going to square root it. So I have 3 radical 6 plus square root of 16 gives me 4 radical 3. Now, for addition, they need to have a common radicand. If they do not, we cannot add them. So in this case, we have 6 and 3. They're not a common radicand, so this is going to be my final answer. 3 radical 6 plus 4 radical 3. Example 2 is going to be where we FOIL. So we have a binomial times a binomial, but we have radicals involved in this. So we need to use our FOIL method. So we're going to start with f, which is multiplying our first term. So 4 times 2, which gives me positive 8. Then I'm going to do my outer terms for my O. So 4 times negative radical 3. So that's going to give me 4 times negative 1 for my coefficients, which is a negative 4. And then I have no radical in this first term, so it's just going to be radical 3. Then I'm doing my inner, so radical 3 and 2. 2 times radical 3, again, coefficients. 2 times 1 is positive 2. And then radical 3, I have no radical in my second one, so it's just going to be radical 3. And then my last term, so I have radical 3 times negative radical 3. So multiplying the coefficients first, I have positive 1 times negative 1, so minus. And then inside my radical, I'm multiplying next. So I have 3 times 3, which is going to give me 9. Next, I'm going to go ahead and simplify this. So going left to right, since it's all addition and subtraction, I don't have to worry about order of operations. I have 8, can't do anything with that. So 8. And then I have negative 4 times radical 3 plus 2 radical 3. I can combine these two because they are like terms since they both have the same radicand. So I'm going to do negative 4 plus 2, leaves me with negative 2, and then my radical stays the same. So radical 3, and then I have minus, and 9 is going to be a perfect square, so I can take this square root of 9 and pull it out, or this radical 9, pull the 9 outside the radical, and it becomes 3. So I have 8 minus 2 radical 3 minus 3. And then I can go one step further because I have this 8 and negative 3 that I can combine. So 8 minus 3 gives me positive 5 minus 2 radical 3. And that is going to be your final answer.